All right, we are recording. Good. All right. Now, changed it up a little bit going into the weekend.
Yeah.
All right. So, at the end of the day, Friday, you got a notice. You should have gotten it via Google Classroom. You should also gotten it via email. Let me see if I can find my Classroom app. Let's go here. Open Classroom. And let's go down. No. Why is it doing that? Because I don't have thing in there. Right here. So, tangent line problem pre-work. Posted that assignment. And
I got it done. I just have to turn it.
Now, here's the directions for that activity. And you join in. So, I just look to see if it's done on the Desmo site. I could care less about it being turned in on Google Classroom, but if you did, great. If not, don't worry about that. But, long story short, is that the one? Nope, that's not the one. This is the one. I know who's done it via the Desmos thing. How many of y'all did this? And those of you that didn't see the notice on Google Classroom, I gave you an out this morning. What was the out this morning? Caleb, what prompted you to do this work at 8 o'clock this morning?
I got missing classroom.
On Infinite Campus,
Yeah,
right?
grade dropped.
Yeah, so if you were paying attention to Google Classroom, you got notice of this. If you're paying attention to Infinite Campus, you got this. Okay, so if you didn't do this, either A, you're not tuned into the class using the tools that we've given you, or B, you just don't care. Now, I had, in addition to the people that noticed it on Friday, and I used a test group, didn't I? Y'all in the afternoon were my test group, right? So in the morning, I didn't tell y'all guys in the classroom. In the afternoon, I did, right? Who's here in the afternoon on Friday? So you guys heard about this on Friday, right? Those of you that were here in the morning, and why do you think I did it like this? Just because I like pulling tricks on you guys? Why do you think I did it that way? Who uses the tools that we've given you, yes? Yes. Yes, I did. And so, the thing is a lot of you guys are going to be going off to college next year. Some of you guys are going to be seniors next year. Regardless of what camp you're in, though, the rules are going to change for you soon. The rules are going to change. Okay? What's our policy on late work here?
You can just redo it.
If you don't like your grade, you can redo it. If you turn in late, no big deal, right?
Yeah.
You think that stuff plays in college?
No.
No? You want to get laughed at?
No.
Ask a professor about retake policy. They'll literally laugh at you. Okay? So the rules are about to change. What's that mean to you guys? It means y'all need to be on point. Meaning that learning is no longer a passive process for y'all. You can't just show up and expect to pass after high school. It's not going to work. They're going to expect you to be paying attention. They're going to be expecting you to make connections that they don't necessarily say. So not only does using all the tools available to you apply, but the you never told me bit is not going to fly anymore. Okay? There's a bunch of stuff that we learned in this class that doesn't necessarily get spoken out loud, right? I can infer things. If I say f of x equals the square root of x plus 3, and I want to know what f of 3 are, let's keep it simple. F of 6, what's f of 6?
3.
Why not negative 3?
Plus or minus 3.
No, it's 3. It's 3, because if this answer is plus or minus 3, is it a function anymore? No. And we learned that, right? We learned that you can infer stuff from how we write it. The fact that I call it a function, right, means it has to be the positive. Now, if it was this, then it would be negative 3. But it's this, so it's positive 3. We don't do plus or minus when I'm in function notation. That's what I mean by inferring, right? Do I say that specifically when I write this? But we know because it's written as a function, and the function has to pass what?
Vertical line.
The vertical line test. And if it's plus or minus 3, is it passing the vertical line test? Okay, so long story short, these things matter. Now, what I wanted to do today is hit the ground running, because do we have a lot of time left to us? No. Seniors.
7 days.
6 days. Not counting today. 6 more days. Right? This is day 7. After this is 6 more days. We're supposed to get through derivatives and integrals in 6 days. Ain't going to happen. We're ending this class after this lesson. This lesson is going to take today and tomorrow. Then we go through review, and we're going to do tests on Wednesday. Same day that you all seen your final projects done. You follow? So that means communication is even more essential. Now, why did I choose May to spring this lesson on you? Frankly, it's because I don't think we've learned it yet. Okay? You need to be on point. You need to be paying attention. You need to be paying attention, because a lot of stuff's going to get said that's not actually said. And the ones that are following what they're supposed to be doing, paying attention to details, are the ones that are going to pick up on this stuff, right? It's just like robotics, right, Josh? The little things matter in robotics, right? The things that not everybody's talking about, they matter. Same thing goes in football, right, Caleb?
Yes, sir.
You got to block the right way. Otherwise, you get put on your butt, right? You want to break your wrist through the strike zone, not back here in the back of the strike zone, right? You want to follow through when you throw. You want to hold that gooseneck on your shot. The little things matter. You want to control your breathing when you're running, right? Little things matter. They matter here too. So when you're given an activity by your teacher, they're doing this to help you. They're doing this so that you can get an idea as to what the heck it is we're talking about before we actually talk about it. Okay? This is important, especially if you intend to follow into math going forward. So if you're going into computer engineering, if you're going into data science, shoot, if you're doing any sort of data analysis whatsoever, meaning you're going to be a manager. Sales manager? Math. Right? Project manager? Math. All this stuff matters. Okay? I'm done with my soapbox for right now. How many of you are on this anonymized list of people that did it? So I got 2 here. Okay. Now, one of yous, tell me, what's that about?
Tangent lines.
What about tangent lines? Why do we use tangent lines in that activity? Find the slope of a line is easy, right? Isn't it? What about that one? Is it easy to find slope of that curve? Give me some reasons why it's not easy to find the slope of that curve.
Changing all the time.
It's changing all the time. That's probably the best reason, right? So my slope depends on where I am on that curve, right? Now, point A. When my slope or when my curve is at point A, am I a positive slope, a negative slope, or a zero slope?
Negative.
Why am I negative, Kai? Why is my slope negative at point A? What does negative slope mean?
Down.
It means going down from left to right, right? If I'm over here following on my curve, I am going down, down, down the ladder, right? Negative slope. As x gets bigger, as delta x is positive, my delta y is negative. At point B, what's my slope at point B? Is it 0, is it negative, or is it positive? 0, right? Here it's negative, right? And then it stops, and then it starts going up again, which means the slope is positive after that point, right? What's it got to go through to get from negative to positive? It's got to go through 0, okay? So we can intuit, we can figure out what some of these slopes are at some points, right? Whenever I see a crest or a trough, what's the slope at that crest or trough? 0, right? At the top of a hump or at the bottom of a valley, the slope's got to be 0. Okay? Now, we can draw a tangent line. Kaylee, do you remember what a tangent line is for the... I'm blocking the screen. Yeah, so I draw a line, I grab my ruler and draw a straight line that only touches my curve at one point. If it touches at only one point, it's a tangent. Does this look like a tangent? The blue line with regards to the red line. It looks like a tangent, right? Now, I think, if I remember correctly, -6 is the slope of that point, of that blue line. And that's a decent estimate for the slope of this line, right? Is it exact? Well, maybe. Maybe we got it perfectly right. But maybe this one's perfectly right. Because this line looks like a tangent too, doesn't it? Doesn't that line look like a tangent, Kai? Looks like it only touches at point A, doesn't it? But if I look, and if I do the math, -6.5 is the slope of that line. So how do I know which one is right? Answer is I don't, do I? So this term, or this method, it's limited in its functionality. Meaning, I don't know if I got the right answer or not. I don't know if I got the exact right answer. I get a good estimate, right, Zoe? I might be within 1, but I don't get an exact answer. So what do? Let's change our approach. Instead of trying to draw a tangent, because I know that's foolish of me, because I can't do it, I'm just going to connect 2 points on that curve. I'm going to connect 2 points of that curve. Okay? I'm going to draw a blue line through both of those points. I'm going to calculate the slope of the blue line. I can do that, right? What's that get me?
-3.
Yeah. My change in x is 1. My change in y is -3. So -3 over 1 is -3. Okay. Now, as my gap, so now my slope, my first estimate was -3. Okay? Now, I'm choosing a second point that's closer to that original point A. And those are the 2 points. What is the slope of that line, of that blue line? You get change in y over change in x, right? Which equals what? Yeah. So 1 minus a negative 2 point, or no, I'm sorry. Yeah. Negative 1 minus a negative 1.25 over 0 minus 0.5. The top is 2.25 because I'm adding a positive now. On the bottom, divided by negative 0.5. Divided by a half means times 2, right? So 4.5, negative 4.5. So I went from negative 3 being my slope to negative 4.5 being my slope. Do you think this negative 4.5 is closer to the actual slope at point A or the negative 3? The negative 4.5, right? Now, if I choose a point that's even closer to 0, 1 on the red curve and connect those 2 dots, should I get a still more accurate slope, Logan? Yeah, I should, right? I'm going to call that distance between point A and my other point on that function, I'm going to call that change in x value, I'm going to call that h. Okay? So the horizontal distance between point A and my other point is going to be h. Okay? So if x is 0, my other point, my x at point A is 0, right? My other x would be 0 plus h, right? Or just h. So now, let's get rid of this. So now we're going to change our notation a little bit. Instead of using 0.5, I'm going to use that h. I'm going to use that h. See what we got here. We got some good looking stuff right here. I got f of 0 minus f of 0 plus h. So the directions in this step of our activity was to figure out what the slope is of this line for some given point h comma f of h. Or f of 0 plus h is how I asked you to do it. And Ms. Cheng, Eugenia Cheng, Victor Newman.
Yeah, why is that?
Giuseppe Piano. All these guys give me good work. Christine Ladd.
Did you just give us random names?
George Cantor. Yeah, I anonymized this stuff because reasons. These are all famous mathematicians, by the way. Hipparchus, Jesse Wilkins Jr. F's are my y values, right? When I'm figuring out slope, do y values go in the denominator? No. Okay. Mary Cartwright, good. Leonardo Fibonacci. Ooh, even putting some limit notation in, which is jumping ahead a little bit, but I'll take it. Good. So, as h gets smaller, though, the point is, as h gets smaller, my slope should get more and more precise, right? So, what's this but about? But, what happens when h equals 0? Because that's the closest I can get to my original x, right? What happens when h becomes 0? It's just a point, so geometrically it means We're on the same point, right? Can I compute slope by the same point? I need 2 points, right? What happens when I try and figure out the slope at 1 point? If I use 1 point twice, I get 0 over 0, right? And can I divide by 0? No. But there's that. How can I use limits to analyze this? How can I use limits? Grace Hopper, I'm on the right track, but not quite. She's a Navy gal. Called her Amazing Grace. She's one of the pioneers of computer programming. Anybody ever heard of the ENIAC and the INAC? You've heard of computer bugs, right? You know why they call them computer bugs? Well, the first computer bug was a bug. So they used to have, instead of transistors, they used to have vacuum tubes, which were basically light bulbs that got really hot, right? And they cast off light. And what happens to light bulbs on a street corner? Moths fly around it, right? Moth found its way into the computer room where all these light bulbs were, flew into a light bulb, blew up the computer. First computer bug was a bug, literally. That's why they call them bugs. So, Grace is on the right track, though. Let's see if, yes, the limit as h approaches 0 of this stuff, the limit doesn't equal 0. The limit's going to come to a discrete number, and we're going to go over that. The limit as, this is x approaches 0, but I really don't want x to be 0 necessarily, do I? I want my distance between a given x and another point to be 0. Okay, that's the limit I'm evaluating. All right? And that was the activity. Okay? This is what you guys, those of you that didn't do the activity, this is what you missed over the weekend. This is what I wanted to build off of. Okay? And so, long story short, where is it? I got too many things open. Is it right here? Nope, it's not right there. Is it right here? Yep. We're going to build off of this function. We're going to figure out this function right here. F of x equals 3x squared minus 6x plus 1. Okay? That's our function. You see what it looks like?
Yeah.
All right? Now, we're going to start a new smart notebook page. And we're going to use our knowledge of limits to figure out what the derivative of this function is. Who's heard that term before? Derivative. Okay. Well, I'm going to give that to you. You're going to get that today. Okay? What was that? The derivative. So the first thing. The derivative of f of x. It is a function. Why am I underlining that? Why am I underlining that? Because it's important. It's important for you to understand that the derivative is a function. That gives you the slope of f of x at x. So what does that mean? That means if I want to know the slope at x equals 2, I evaluate the derivative of f equals 2, or x equals 2. Okay? I'm not done here. We annotate the derivative as follows. F prime of x. So that little tally mark next to the f, between the f and the x, that's the prime part, okay? When you see this prime here, then you know I'm talking about the derivative of f, okay? So what would be the derivative of g of x? G prime of x. The derivative would be g prime of x. Okay? Does that make sense so far? Now, our function was f of x equals 3x squared minus 6x plus 1? Okay. Now, remember, I wanted to analyze the limit as h approaches 0 of f of x plus h minus f of x over what? This gives me my what in slope?
Change in y.
The change in y, the rise, right? What do I want here?
X plus no.
Well, if I got my 2 points are x plus h and x, what's my change in x? Right? Because x plus h minus x is going to get me what? Just h, right? Okay. So now, what do? I figure out this guy, right? And I figure out this, well, I don't need to figure out this guy because it's already figured out for me, right? But I figure out this guy. So let's do that in blue over here. F of x plus h equals what? 3 times the quantity what? What do I do with x plus h if I want to know what f of x plus h is? Everywhere I see an x in my original function, I do what? Put x plus h there. Well, I see an x being squared here, so what should be squared here? X plus h. And then it's minus 6 times x, so it should be minus 6 times x plus h, right? And then plus 1. Sorry, I ran out of room over here. But we know what x plus h is, quantity squared, don't we? So we're going to carry this on down here. I got f of x plus h equals 3 times. Y'all square that for me, see what you get.
X squared plus.
Inside voice, right on your paper. Let other people do. Beautiful. Beautiful. Finish the rest of it while you're at it. Good work. Good. Finish the rest of this line. That's good work, Caleb. Nice. Distributed the negative there. I like that. Good. 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 Nice. All right. So we got x squared plus 2xh plus h squared, yes? And then if we distribute that negative 6 throughout this term, we get minus 6x minus 6h and plus 1, right? All right, this hot garbage, let's simplify it further, shall we? This equals, let's distribute the 3. I get 3x squared plus 6xh plus 3h squared minus 6x minus 6h plus 1. That is going right here. Okay? Riddle me this, Batman. Why can't I just do direct substitution right up there? Why do all this work? Maybe I should have started with that, eh? Why not put h, 0 in for h? Yeah, I can't divide by 0, so I have to use some of my other limit tricks, right? I got to do that first before I can evaluate this using direct substitution. Okay, so let's substitute this blue thing right here, in for x plus h. So I got remember the limit as h approaches 0, remember that notation of, now let's put this in blue, 3x squared plus 6xh plus 3h squared minus 6x minus 6h plus 1. All right? And then I'm going to do my original f of x in red. Minus, why am I putting in parentheses? Why do I put it in parentheses? So I can distribute the negative later, right? Because if I don't put that parenthesis in, it just means the minus 3x squared, right? So I got minus 3x squared minus 6x plus 1. And then I go boom, 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 boom. I don't know why that changed color in midstream like that, do you? Oh well. It's pretty freaky deaky, isn't it? And that's all over H. Okay, now, can I simplify this hot mess? God help me if I can't, right? Probably. What are you thinking, Ben? Let's do this in green. You say this 3x squared can go away? Why?
3x squared in the red.
Ah, there. That's being subtracted from that. Those go away. Ah, 6x, negative and positive, right?
And the 1.
And the 1. Oh, goody. Now, I got, this might be more manageable. I got the limit as h approaches 0 of, let's see, 6xh plus 3h squared minus 6h all over h. Remember your limit notation. Remember your limit notation. Did I hand quizzes back to you on Friday? If I haven't handed them back to you, that means I misplaced them. If I misplaced them, that means I'm in trouble.
Did we take a quiz on Friday?
Did we take it on Friday? And I put it in the grade book, right?
Yeah.
Oh, they're right here. Look at that. I'm trying to be organized. Every time I try and be organized, I bite myself in the butt. Let me get these scanned. I'll hand them back to you all tomorrow, all right? All right. What can I do here?
Take out an H.
Factor in h out of the numerator, right? This equals the limit as h approaches 0 of h times what?
6x.
6x. Next. Plus what? Riley.
3h squared.
H times what gets me 3h squared? What goes in here? 3h, right? Because I'm factoring out an h, right? And then minus what? 6. You follow that, Riley? You following this?
Yeah.
All over h.
Then you cross them out.
Then I divide those things out. And then I'm left with,
What's the deal?
well, I'm left with the limit as h approaches 0 of 6x plus 3h minus 6. Now I can do what, Henry? Direct substitute. So, when h equals 0, what happens to this guy?
Bye.
Bye-bye, right? So this equals 6x minus 6. Notice the limit notation is gone now, yes?
Yeah. So that can be.
So what is this? What do I call this again? The derivative. What is the derivative? It's a function. How do I annotate this function?
Oh.
The original function was f, right? F prime of x. You got that?
Yeah.
You got that. All right. Got that. You just did calculus. Now, who wants the rule that you won't be able to use in this class, but you'll be able to use next year when you earn that privilege in calculus? Who wants the rule?
Sure.
You want the rule, Josh? It's called the power rule. Anytime you're finding the derivative of a polynomial, was this a polynomial?
Yeah.
Yeah. What degree polynomial?
2.
Second degree polynomial, right? When you find the derivative of a polynomial, you take the power, multiply it by the coefficient. Then you take the power and reduce it by 1. And you do that for every single term. What's the power here? 1 times negative 6 is? It's negative 6 still. 1 times negative 6 is negative 6. And then you reduce the power by 1. So you get x to the 0 power, which, do I even write that?
No.
And then you stop there. You stop there. Why does it make sense I stop here? What does this guy do to my function? If I didn't have this plus 1 in my function, what does that do to it? It just moves it down a step, right? So does this plus 1 change the slope of my function in any way, shape, or form? So this guy doesn't matter. So that's my derivative. Did I get that down here? I did. So what I've given you is, when you're doing this on the test next Wednesday, I've given you a method to check your own work. Because you need practice at algebra, my man. You need practice at algebra. You need practice with limits. And in order to earn the right to use these tools, you need to know why they're justified. Otherwise, you're just some sort of egghead math guy who thinks he's better than the guy he's talking to. You need to know this. All right?
Where did you get, can you go back up to where you wrote that?
This? There is no homework today. I will put out the assignment tomorrow. The assignment for the rest of you all, other than the 2 who did this assignment today, is do that Desmos activity. All right? It does not work very well on your cell phone.
Yeah.
Do it on a computer. Is that going to be a problem for anybody? Y'all should have computers, right? With interweb capability. All right. And juniors, sophomores, and freshmen, we will be doing another one of these after the seniors book. Yeah. It's got more colors and equations, so we'll like it.
Mr. Cook, can you take a look at this?
Yes, sir. Let me get this.
I did my logo. I'm just trying to figure out what I can like add on to it.
Give me a hot second.
You finished your logo?
It's not.
So you've interesting.
Yeah, but it's not good. It's not good enough. I need some more functions. So what I did was I'm missing a sign. I'm missing a log.
These had function.
Yeah. I did a circle.
All right. What you got there, Slug?
So I did this first, right? I'm trying to figure this out. So
Okay.
this line right here. I want to try to make it curve so I can get this. I'm trying to make it curve.
You want to make a curve in what shape?
Trying to like
Logarithm.
yeah, like
Or sine, maybe.
Well, a logarithm's just going to do that, right?
Yeah.
It's just going to go. It's going to keep going up, right? So you can do that, but know that it's now a sine will go up and then down.
Yeah, that's
A
right.
parabola would go up and down.
Yeah, the sign. I'm trying to figure it out with like how to do it like that.
Okay.
So would I have to like write sign in front of it, or I
Well, just taking the sine of it, try it. See what happens.
it moves. It just moves down.
Yeah, it moves down there. Because think about this. You're taking the sine of this function, right?
Yeah.
And that's the constant function at x equals 16.
Yeah.
That's just x equals 16. So when I take sine of x, I'm taking the sine of 16, right? And that's always going to be the same number, right? No matter what x is. You feel me? So
Figure out.
So one thing, this looks like 16 divided by some stuff. It's working for you?
Yeah, it's like 16 divided by like the circle.
Well, here's what you could do. I would, and this is how I would choose to do it, is because your notation is kind of messy right there, and it might get you into trouble later on. But here's what I would do. I would say f of x equals 16, right? And then next to it here, you'd set your domain. It's what? 0 less than or equal to x less than or equal to 4.
Okay.
And I think if you change this to a less than or equal to, then you can shade anything below it.
Okay.
You know what I mean? But you got an equal sign, so it's just going to be a line.
Okay.
You got that?
Yeah.
That's how I would do that.
Do you have another rubric for the thing?
It's on the classroom.
Oh, it is?
Yeah.
So you didn't give one out?
I did not give paper out,
I
no.
thought I lost it. So.
No, I suck at paper.
Yeah, so.
Well, then you should like the
Yeah.
fact that it's on classroom. Mm-hmm.
When can I take my 11 my 2?
No time like the present.
I'm one mod after that.
It shouldn't take you too long. So if you want to, you can do it now. And if you don't finish, you can
Come back.
hold off on it until you come back.
Okay.
You down with that plan?
Yeah.
All right, let me get you that. Where did I put it?
Where do you want the homework?
Top right. There you go. You may use a calculator. I don't think you'll need one, but you may use it. What did I do with my thingamabob? It's got to be over here someplace.
Your what about?
My holdy thing. There it is. There it is.
We're still recording.
Yeah.
For making the matrices, for quadratics, did you use like a calculator for that, or you do them all by hand?
We will do them all by hand, but we can set up usually we don't even, there's a way to do it on a graphing calculator, not on that calculator, but on a graphing calculator, yes. And there's also ways to do it on like Excel or Google Sheets. And maybe we'll do that after the seniors leave. We'll do one of those on Google Sheets.